Hello everyone, welcome back to my YouTube channel. This is Sangeeta Piche from Sri Venkateshwara College of Engineering from the Department of Information Science and Engineering, third semester. Today in this video, we are going to discuss about the subject data structure and applications, and our topic is single and double-ended priority queues. Let's move on to the video. Comprehensive overview of priority queues. Priority queues are a fundamental data structure in computer science. They are essential for various applications, particularly when handling tasks or elements with different levels of importance. This presentation provides a detailed exploration of single-ended and double-ended priority queues, their operations, and their practical applications. Definition of priority queues. A priority queue is a data structure that maintains a collection of elements, each associated with a priority. The primary operation of a priority queue is to extract the element with the highest or lowest priority. Let's move on to the key characteristic of the priority queue, which is elements are organized based on their priority. Priority based operations. Operations prioritize elements with higher or lower values. Applications. Widely used in operating systems, scheduling, and networking. And the priority queues follows the rule which is first in, first out. What is a priority queue? It's an organized collection, a data structure that stores elements based on their priority. Prioritized access allows for efficient retrieval of the highest priority element. Real world applications widely used in operating systems, scheduling, and task management. Single ended priority queues. Single ended priority queues allow insertion and extraction from only one end, typically colored the front or rear. They are ideal for scenarios where processing elements in order of priority is the primary requirement. Insertion. New elements are added based on their priority. Extraction. The highest or lowest priority element is removed. Implementation. Common implementations include heaps and binary trees. Operations in single-ended priority queues. Single-ended priority queues supports a set of common operations to manage elements and maintain priority order. These operations are essential for efficient data management. The operations we use to follow in single-ended priority queues are insert, extract max or extract min, and p. Insert adds a new element with its priority. Extract max or extract min is used to remove the highest or lowest priority element. Peak retrieves the highest or lowest priority element without removing it. Double-ended priority queues. Double-ended priority queues are also known as dequeue. Allow insertion and extraction from both the ends, which is not possible in single-ended priority queues, and we can see in the diagram here we mentioned in this. This provides flexibility in scenarios where processing elements from either end is necessary. Front operations. Similar to single-ended queues with insertion and extraction from the front. Rear operations enable insertion and extraction from the rear end, adding more flexibility. Applications useful in real time systems where processing from both ends is required. Operations in double ended priority queues. Double ended priority queues provide a wider range of operations compared to their single ended counterparts, allowing for more flexible data management. Here we mention some of the operations for single-ended and double-ended priority queues in the table. Comparison of single-ended and double-ended priority queues. Choosing between single-ended and double-ended priority queues depends on the specific application requirements and the desired level of flexibility. Single-ended priority queue is efficient for processing in priority order from one end, whereas the double-ended priority queue is more flexible, allowing for processing from both the ends. Applications of priority queues. Priority queues find widespread applications across various fields, enhancing efficiency and optimizing resource allocation in numerous scenarios. Some of the applications of priority queues are task scheduling, event handling, network routing, and algorithms. Let's move to the task scheduling. Prioritize tasks based on importance, deadlines, or resource requirements. Event handling. Process events in order of their priority, ensuring timely responses to critical events. Network routing. Determine the shortest or most efficient path for data packets. Algorithms. Implement efficient algorithms such as Dijkstra's algorithm for shortest path finding. Implementation of priority queues. Priority queues can be implemented using various data structures, each with its own advantages and disadvantages. The choice depends on the specific applications and performance requirements. Heaps. Binary heaps provide efficient insertion, deletion, and retrieval operations. Binary search trees allow for efficient searching and sorting of elements in a priority queue. Sorted arrays suitable for smaller queues, but insertion and deletion can be inefficient here. Operations on a priority queue. Insertion is also known as enqueue. Adds a new element to the queue, maintaining the priority order. Deletion, which is also known as dequeue, removes the highest priority element from the queue. Peak returns the highest priority element without actually removing it. Size returns the number of elements in the queue. Single-ended priority queue. Elements can only be inserted at the end and removed from the beginning. This is also known as first in, first out concept. Implementation typically uses a heap data structure to efficiently manage priorities. Let us move on to a real life example for single ended priority queue, and that is think of a queue waiting line in a hospital where patients are treated based on their severities. Implementation of a single ended priority queue. Heap, a binary tree based structure where the parent node always has a higher priority than its children. Insertion, adding an element involves heapifying the tree to maintain priority order. Deletion, removing the highest priority element, which is known as root, involves replacing it with the last element and heapifying. Time complexity of single-ended priority queue operations. Insertion, which is also known as enqueue. Time taken to insert an element scales logarithmically with the number of elements. Deletion is also known as dequeue. Time taken to remove the highest priority element scales logarithmically. Peak, constant time to assess the highest priority element. Double-ended priority queue. Elements can be inserted and removed from both the ends, which is not possible in single-ended priority queue with the highest priority at each the end. Implementation uses two heaps, one for the front and one for the back, maintaining priorities on both the ends. And let's move on to the real life example. Think of a two-way street with two lanes where cars with the highest priority can enter from either end. Implementation of a double-ended priority queue. Two heaps, one for the front and one for the back, each maintaining priority order. Insertion. Adding elements to either end involves inserting them into the corresponding heap. Deletion. Removing from either end involves deleting the highest priority element from the corresponding heap. Time complexity of double-ended priority queue. Insertion. Time taken to insert an element scales logarithmically with the number of elements. Deletion. Time taken to remove the highest priority element from either end scales logarithmically. Peak. Constant time to assess the highest priority element at either end. Conclusion and key takeaways. Priority queues are essential data structures for managing tasks and elements with varying priorities. They are highly versatile and find applications in diverse areas. Understanding their characteristics and operations is crucial for developing efficient and optimized solutions in various domains. Thank you for watching. Please do like, share, and subscribe to my YouTube channel if you like this video.